This video is on the objective determine the p-value for a hypothesis test for the mean of the differences for the paired data. Alright, so let's take a look. So again, if you're unfamiliar with the topic, want to see more about it, click on more instruction at the bottom and look at their notes, their videos, their examples, and hopefully all those help you out. Alright, so your friend believes that he has found a route to work that would make your commute faster than what it currently is under similar conditions. Suppose that data were collected for a random set of 7 days, where each difference is calculated by subtracting the time taken on the current route from the time taken on the new route. Alright, so you're taking your new route time minus the old route or current route time. Assume that the populations are normally distributed. Your friend uses the alternative hypothesis, the difference between these route times on average is less than 0, is negative. That means that the new route times are smaller than the old route times on average. Right? That means you're commuting there faster, in shorter times. So this alternative hypothesis that mu d is less than 0 is saying that on average this new route is faster. Suppose that the test statistic t is computed at negative 3.201, and the t distribution here would have 6 degrees of freedom, right? One less than the size, and the number of pairs of data we're looking at. There would be 7 pairs of data here, so 6 degrees of freedom. What range contains the p-value? Alright, I'll draw a little picture. The distribution of the mean differences would be a t distribution, again with 6 degrees of freedom. They told us, the alternative hypothesis was that the average difference for the population is less than 0. And if that's the way the alternative hypothesis looks, that the parameter is less than a value, that means you're running a left-tailed test. And I'll draw a t distribution here, a student's t distribution, right? So the number line represents t scores. Got a symmetrical bell-shaped curve above that. Underneath the peak, right, is a t-score of 0. And then for p-value, remember you need to know where your test statistic lies. They said the test statistic came in at negative 3.201. Right, there was the test statistic. And if this is a left-tailed test, the p-value of your test statistic is then the area to the left. Right, if this were a right-tailed test, the p-value would be area to the right. But the p-value is this area to the left, which I can find on my calculator. Right? I'll show you how to find. Remember, this is a t distribution. So if I go to that distributions area, right, second, and then above the variables button, distributions, and we're finding the area under a t distribution. So I go down to t-CDF. This area to the left here, there is no lower boundary, so I'll just put in some big negative number. And the upper boundary is my test statistic, negative 3.201. And the number of degrees of freedom for this distribution was 6. And this area is approximately 0.009. If I round 3 decimal places, 0.009. So you could have found the p-value using your calculator. Now they're asking us to tell us, what is this between, using our table. Now this is between 0.5% and 1%. We're going to see that here in the table in a second. So I'm looking at this 6 degrees of freedom row, and the test statistic is negative 3.201, but these are all positive values. So I'm going to look at where does positive 3.201 lie? Well, it's bigger than this, it's bigger than this, it's bigger than this, it's bigger than this, but not bigger than this. So, the 3.201 falls between 3.143 and 3.707. Now the area to the right of 3.103 or 143 is 1%. The area to the right of 3.707 is 0.5%. So the area to the right of positive 3.201 would be between 0.5% and 1%. So that means the area to the left of negative 3.201 would also be between 0.5% and 1%, and those are the values, right? And we're between 0.5% and 1%, or just less than 1%. Now this is the only one that seems to actually make any sense, that seems to fit. So the p-value would be less than 1%, which we saw, right? We saw that on my paper. The p-value is 0.009. It's definitely less than 1%. So you could find it with the calculator if you want, or look at the table and still deduce this. All right, and that's all. All right, that's all we're doing here. So hopefully watching me talk about it, write some stuff out, looking at the more instruction if necessary, reading these answer explanations, whenever they show up. Hopefully all this stuff helps you out when you're doing this material on your own. And thanks for watching.